Hi everyone, welcome to talk session. Let's continue with few more examples on designing of DFA. Here question is design DFA to accept all binary numbers divisible by 5. As I explained in my previous videos, pattern of question like binary, ternary, decimal numbers may be divisible by 2, 3, 5. For this pattern of questions, we'll be using one trick. How it works? Let's start. Here divisible by 5, so there will be 5 states. States will be like this: Q0 or Q1, Q2, Q3 and Q4. So these will be the 5 states. Binary numbers they have mentioned. So we know binary number consists of 0 and 1. So this will be our input set sigma. Now first write down the state transition table, and from table you can easily convert to diagram. So how to write down the table? How many states? Write down it: Q0, Q1, Q2, Q3 and Q4. As I explained in previously videos also, that in such typical question pattern of question, Q0 will always starting state and it always final state. That you need to remember. What's the input set? 0, 1. How to fill this table now? It's very simple. Write down the name of state sequentially row wise. Row wise means what? First row. Name of the state sequentially: Q0, Q1. What's the next state? Q2, Q3, next state is Q4. You just need to write down sequentially row wise. So first row, second row, third row, all the name of the states are over. Again start from the first state: Q0, Q1, Q2, Q3 and Q4. Your answer is ready. As we know table is ready, we can easily convert to diagram. How many states are there? 5 states. So write down the 5 state first. Q0 is the starting as well as final in these typical questions. So Q0 is the starting state. Next one is Q1, non-final. Next one is Q2, it's also non-final. All remaining states are non-final states, Q3 and Q4. Now how to give transition? It's very simple. Q0 reading 0 going to Q0. First give transition for simplicity. Q0 going to Q0 for symbol 0, then give the label. Q0 going to Q1, Q0 going to Q1, but for which symbol? Symbol is 1. First row is completed. Second row, Q1 going to Q2 for 0, Q1 going to Q2 for 0, Q1 going to Q3 for symbol 1, Q1 going to Q3 for symbol 1. Second row is also completed. Third row, Q2 going to Q4 for 0, Q2 going to Q4 for 0. Then Q2 is a state going to Q0 for 1, Q2 going to Q0 for 1. Third row is completed. Next row, Q3 reading 0 going to Q1, or you can say Q3 is going to Q1, Q3 is going to Q1. But for which symbol? Symbol is 0 here. You can write down here. Q3 going to Q1 for symbol 0. Q3 going to Q2 for symbol 1. Q3 going to Q2 for symbol 1. This row also completed. Last row, Q4 going to Q3. Q4 going to Q3. But for which symbol? Symbol is 0. So give the label. Q4 is going to Q4 means self-loop for symbol 1, symbol 1, and this becomes your final DFA and this is your answer. If you want to verify, you can verify which are the binary numbers divisible by 5. It may be 5, it may be 10. What is the 5 binary notation? 101. Start reading. Our automata starts with Q0. First symbol is 1. Q0 reading 1 going to state Q1. Q1 reading 0. Q1 reading 0 going to state Q2. Q2 reading the next symbol 1, Q2 reading the last symbol 1 going to state Q0. So after reading the complete string, automata is in the state Q0. Q0 is a final state, hence 101 accepted. It should get accepted because 101 is nothing but 5 and 5 is divisible by 5. Hence our automata is correct one. You can verify for the 10, you can verify for the 15 or any number. Convert these numbers into binary it becomes your string something in terms of 11 or 10 notation, and verify this whether these binary numbers divisible by 5 are going to accept by this automata or not. After reading this string, automata should go to the final state. The next session will be learning design DFA to accept all ternary numbers. In this case, it will be ternary numbers divisible by 2. Thank you for watching.